Now we're going to look at conditional probabilities. We've got 2 dice. We want to know the probability of getting a total of 8 on the 2 dice, given that both dice are different. That is, you don't get the same number in both dice. Now that means you're not going to get the 8 by getting a 4 and a 4. The sample space for this probability can be thought of as being only 30. The size of the sample space is only 30, because you have 36 possibilities with 2 dice, but 6 of those are the ones for both dice give you the same result. So the probability of getting a total of 8 where both are different is going to be computed within that smaller sample space where they're both different. Okay? Another way of saying that is, of course, that there's 6 possibilities for what the first dice comes up, and only 5 for the second, because it can't be the same as the first. Or if it is, we're not going to count it. Okay, so how many ways are there to get 8 in this new space where none of the dice come out the same? The 2 dice come out different. Well, we can get 8 by a 6-2, by a 5-3, by a 3-5, or by a 2-6. So the probability of 8, given that the things are different, is 4 out of 30. Okay? Now, this is n of 8 and different. Okay? In other words, there are 4 ways to get 8 and different. There are 30 ways to get 2 different. So we divide the number of 8 and different by the number of different. If this is the probability of A given B, we divide the number of ways to get A and B by the number of ways to get B. And of course, that's what we express here. Probability of A given B is a probability of A and B divided by the probability of B. We can depict this in a diagram, a Venn diagram, if we've got event A and event B, and we want to know what's the probability that we get A if it's known that we're in B. That's what this means. It's known that B occurs, so we have to be in this circle. Now, what's the probability of getting A? Well, since it's known that we're in this circle, we just restrict our universe to this circle. Now, the number here is the number in the set B, and here's the number that are also in A. Okay, just taking this picture and just taking the B part, we see that the number that are A's within the set B is the number in A intersection B, because what we have here is the intersection.